electricity. We are going to start with basic electricity, and but before I start, let me tell to you something. What is the difference between the electrical wiring in your home and the electrical wiring in your boat? What is the difference? Why my home is a little different than my boat? The main difference is that in your home you only have AC power, AC outlets, AC breakers. In your boat you have AC and DC. And you have AC panel, DC panel. In some cases you have AC panel, DC panel, electronics DC panel, other sub panel. This is the main difference. You have two currents flowing in a flowing element. What is the other difference? Very important difference between your home and your boat. Okay, number one, you have DC and AC in your boat. The second one is very, very important. If you have cleared that difference, probably you avoid a lot of problems in the future. The ground. Where is located the ground in your home? You remember that rod in the backyard? And all the grounds converge in that point. This is in your home. Where is located the ground in your boat? The anode that you have in the transom or in the side of the boat, depending of the boat. This is the ground in your boat, and the other one is the ground in your house. This is a very, very important factor. Later, in the next coming chapter, we are going to study how important is in your boat the proper connection of that ground, the proper wiring of that ground. You can destroy your boat if that ground is improperly connected or not connected. The corrosion will be accelerated and your boat will be going down. All right, good. Because now we understand that we have two types of currents. What type of current you have in your boat? AC current and DC current. No? AC current and DC. Where is coming the AC current in your boat? The shore power, the pedestal. The pedestal is the building, no? Is the house. Is the grid. The second one, AC. AC source of power in your boat. The generator. The generator. Number three. The inverter. Convert DC into AC. Three sources of power. AC in your boat. Sources of DC current in your boat. DC. Excuse me? Okay, solar panels, solar power, wind, other one?
Battery.
The batteries, the battery bank. The battery bank is used to storage energy collected from the solar panels.
Alternator.
The alternator, the battery charger. The alternator is a battery charger.
Is a rectifier considered?
Yes, the rectifier is a battery charger. Yes, but in your boat, we have the battery bank, we have solar panels, or we have a windmill. To recharge the battery bank, we have alternators and battery chargers. Later we are going to study. Those are the sources of DC. Okay, and now the problem starts in a boat. Because when the people say, I have an electrical problem, what is the first step? When you receive the phone call, oh, I have an electrical problem.
It's the switch on.
Isolate the problem. My problem is AC or DC. If it's AC, it's located here, in the side of the battery, it's AC. Oh, okay, AC, probably on the shore power, probably the generator, yeah? The AC side and the DC side. You need to be careful with that. No mix it. No mix it. This is DC, this is AC. And you need separate the problem, isolate the problem. This is the number one. If you have clear, oh yeah, I know this problem is here in this side, in the side of DC. The problems start, later we are going to see, when you introduce AC current in your boat. Because you introduce the generator. Okay. This is why this class is DC. But let me show you something. This is a small boat. I have lights, I have a DC panel, navigation lights, I have the gauge on the dashboard, temperature, oil pressure, voltmeter, fuel, tachometer, I have the ignition switch, I have the start motor, the alternator, the battery charger, some lights. This is a small boat, and we are going to do the wiring of that small boat. In other words, at the end of this class, you are ready to do the wiring in a small boat, DC. Completely, with gauge, with the oil pressure, temperature, fuel, ignition switch, tachometer, all the gauge. This is DC. This is the first project, okay? And we need later Danny will explain you, we need a good multimeter. This is the tool number 1, good multimeter. I love this brand. Look, it's good, it's excellent, it's accurate, I don't know if it's cheap, I don't think so, but it's good. Okay, good. DC current and AC current. This is why my boat is different, because in my boat I have DC integrated with DC, and in some boats, those stupid designers, engineers, they design the AC panel together with the DC panel and together with the electronics, and produce a confusion to the customer, because the customer mixed a lot of cables. For example, one good example is, what is the color of the hot line in AC current? You remember?
Black.
Black, it's black. And in the majority of the boats, what is the color of the negative in DC?
Black.
If you put the panels together, blacks with blacks, and you can use this black for ground in DC, and this is hot 120. It's very common. I don't like those designs. The panels together. The panels should be separated in a different compartment. AC panel here, DC panel here, with different color codes. We are going to talk about that to avoid confusion. Okay? You are the future of this business, guys. And the future boats depend on you, depend on your criteria, depend on your ideas, how to implement good practice, designing boats, wiring boats. Okay, we are going to start with the electricity and why. You remember in the previous class we talked about the materials recommended in the marine industry? What type of alloys are good, what type of alloys are not good? What is the most famous alloys, ferrous alloys used in the marine industry? Stainless steel, series 304, 316. Thank you, Mr. Javier. What is, give me 2 examples of good non-ferrous alloys used. Non-ferrous. What is the alloy of the propellers, the inboard propellers? Nibral. What is the name of the alloy for the shaft of the propellers? You remember? Aqualloy 17, Aqualloy. Tobin bronze, naval bronze. Those are non-ferrous alloys. Remember that the periodic table is divided in this section. Those elements are metals, and those non-metals. And where are located the most interesting metals?
The group.
That section, no? What is the name of those metals? Transition metals. How many electrons have the metals in this group, in the last orbit? In the last orbit? Two. And this one? 3, 4, 5, 6, 7, and 8. Okay, I have a question. And what about those elements? How many electrons in the last orbit? This one? 3. And this group? Zinc, cadmium, and mercury. 2 electrons in the last orbit. I have a question. Suppose that you have a motorcycle, and you need to stay here at 7 o'clock in the morning every day for the class, and you live in Pompano. What do you think is better? Start your trip at 6:50 in the morning, or at 5 a.m.? How is the traffic at 5 a.m.? It's better, no? You have more space in the expressway. What happened at 7 o'clock in the morning?
Traffic jam.
7:30. That's impossible, no? It's saturated. Okay. What do you think about the flow of electricity in metals with 3 electrons in the last orbit or 5 electrons in the last orbit?
The one with
What
three.
is better for the flow of electricity? 3, because more space for the movement of electrons. This is why the majority of good conductors are located here with 3 electrons in the last orbit, because for the flow of electrons is easy, the movement. This is why we have copper, silver, gold, iron, chromium. All of those metals are excellent conductors of electricity. All the metals are conductors, but some of them are better than other ones. It's clear, guys? Follow me? What is the best conductor here?
Copper.
Okay,
The best one is gold.
it's gold. It's gold, but what is the problem? It's too expensive. Look at this. This group, copper, silver, gold, are excellent conductors. Which one is cheaper in between both those elements? Copper is the cheapest. This is why we use copper to create conductors, wires, cables. Yeah? And which one is more abundant? Copper. Yeah? Of course, gold is better, but can you rewire your sailboat with a gold
I
wires?
don't know if you're rich enough.
That's probably no. You don't have the metal, because this is a lot of metal, and you don't have the money also. No, that's impossible. Okay, but copper is a great conductor, and this is why we are going to use copper in the majority of our cables. Okay, good. That's the most important part. I want to repeat a little about the static electricity. What is the meaning of static electricity? What is static electricity, guys?
Energy.
But why the name
Created by
static?
friction.
What is the difference between dynamic current and static current? Dynamic is in movement. Static, static, no flow. Okay. How you think is created
Friction.
static electricity? Friction. Friction is a good example. Other source of static electricity. Correct. Look at this. Suppose that I have a refrigerator. The refrigerator in my home. You remember when you buy a new appliance, you receive the appliance, you remove the box, new appliance, and you see one small green cable in the body of the frame. What is the function of that green cable connected in the body?
Round out the static.
To drain static electricity. Drain where? On the ground. The ground of your home or the ground of your boat, the grounding. Okay. Suppose that I connect my refrigerator, new one. I connect to the power, and I don't connect that green cable because somebody, a friend of mine in Hialeah, said, that cable is not necessary. That cable is not required. And some people sell extension cords, power extension cords, without the ground cable. They eliminate the ground cable because they consider that the ground is not necessary. I connect my refrigerator to the power with no green cable, and 3 days later, at 2 a.m., I want a little amount of orange juice. I go to the refrigerator, I touch the refrigerator, and I feel, what happened?
Shot.
I drain with my body that
become
current
the ground.
because the ground was not connected. How that amount of current was stored in the case of that equipment? Of course, when you plug it, what happened?
It turns the engine on.
The motor, the compressor is spinning, no? Bam, 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 bam. When the motor is spinning at high speed, the rotor, what happened with some charge? Jumped for centrifugal force. and storage on the case, and stay on the case over there until one guy touch the body and drain the current. Nice, no? This is other source of static electricity. How many sources of static electricity you have in your boat? 1 million. The engine produces static electricity. You know the crankshaft rotating,
The alternator.
the generator, the alternator, the refrigerator, the dishwasher. A lot of equipment produce a lot of static electricity. Excuse me 1 second, Javier. And those equipments should be connected to the ground of your boat. If not, let me finish with that explanation. We are going to continue with the refrigerator. The ground cable is not connected, and a lot of energy is stored on the case of the equipment. Look at this. Additionally, this refrigerator is not marine grade equipment. It's a Home Depot refrigerator in your boat. The housing of the refrigerator is a regular steel. The brackets in the bottom in aluminum, and the rivets, the screws, in copper. How many dissimilar metals are over there? 3 or 4, no? What happened when you have 2 dissimilar metals in a marine environment? The more noble attack the less noble. The less noble release the electron, and the more noble attract. What happened in that boundary, in that area around the more noble with the less noble?
What do you mean?
That area will be eroded. What happened in 2 months with that area? It's attacked with feeding corrosion and is perforated. And you have, wow, the bottom of my refrigerator is completely eroded in 3 months. What is the name of that corrosion when you have 2 dissimilar metals together in a marine environment and the element with more energy attack the element with less energy? What is it? Galvanic corrosion. And what happens if you have that situation, 2 dissimilar metals together, and additionally, for some reasons, internally in that refrigerator, one cable with power is touching the housing? You have electrolysis, because you have galvanic corrosion plus current, and the current accelerates that process. This is part of the course of corrosion, but this is later. Good, guys? It's clear? What is the meaning of static electricity? Is good idea keep the static electricity storage in my boat,
No.
in the metallic elements? No. You need drain immediately. How can you drain that static electricity?
Ground.
With a good ground. Later, I am going to explain the process. But you need to connect all the metallic elements internally in your boat with a common conductor. That process, the process to connect all the metallic elements with that conductor, is the bonding. And after that, that conductor will be connected externally with the sacrificial anodes. This is grounding. And the connection between the relation between those anodes, the water and the ground, this is the ground.